How does necking appear in stress-strain curve analysis? Imagine stretching a piece of metal until it starts to thin out in one spot. That's what engineers call necking, and it shows up clearly on a stress-strain curve. When you look at the curve, you foresee a rising line as the material stretches. This is the elastic region where the deformation is reversible. As you keep pulling, the curve reaches its highest point, called the ultimate tensile strength. After that, the curve begins to dip downward. This decline is where necking begins. Necking shows up because the material can no longer stretch evenly. Instead, deformation localizes in a small area, causing that part to thin out significantly. On the stress-strain curve, this appears as a drop in the nominal stress, even though the strain keeps increasing. The reason is that the nominal stress is calculated using the original cross-sectional area, which stays the same in the calculation but actually gets smaller in the necked region. Meanwhile, the true stress, which considers the current cross-sectional area, continues to rise during necking. This transition from uniform to localized deformation is a mechanical instability. It happens when the material's ability to harden and resist deformation is no longer enough to compensate for the reduction in cross-sectional area. Engineers often use the consider criterion to predict when necking will start. This rule states that necking begins when the rate of increase of true stress with respect to true strain equals the true stress itself. In simple terms, when the material's work hardening can't keep up with the thinning, necking occurs. Recognizing necking on a stress-strain curve is important because it signals the limit of uniform plastic deformation. After this point, the material will likely fracture soon. Ductile materials show a clear necking region, allowing them to absorb a lot of energy before breaking. Brittle materials, on the other hand, tend to fracture right after the elastic limit with little or no necking. In summary, necking appears as a downward bend after the maximum point on the stress-strain curve. It indicates the start of localized deformation, with the cross-sectional area shrinking in a small region. This behavior marks the transition from uniform to non-uniform deformation and is a key factor in understanding how materials will perform under load. Recognizing this helps engineers choose the right materials and design safer, more reliable components.